What's up, everyone? This is LeetCode 230, kth smallest element in a binary search tree. Okay, so we're given the root of a binary search tree, right? And we have to return, and we have an integer k, and we have to return the k smallest value of all the values in the node. So, for example, this is our binary search tree, right? K is equal to 1, so we have to return the first smallest um, element. For example, if this was 3, we'd have to return the third smallest element, right? Here, for example, so I guess we'll go through the answer, right? So what's the first smallest element? Well, obviously it would just be the 1, right? We return the 1. Here, for example, you'll see kind of the gist of this problem. This is a binary search tree we're given. K is equal to 3, so we have to find the third smallest element, which would be 1. It'd be just the 3, right? So this problem's not really too hard. You just have to recognize that we can use in-order traversal to solve this. So obviously, when we do in-order traversal, we're basically grabbing the smallest nodes, then the next smallest, and the next smallest, right? In-order traversal, if you don't remember, you go left, then you go back to the root, and then you go right. So that's kind of how you handle the nodes, right? Left, root, right. Okay, so you can see we go all the way left, then we go up, handle the root, then we go to the right, right? So that's just in-order traversal, and we can use that to solve this problem, okay? So, just some basic DFS type, um, or so kind of, we're gonna do in-order traversal, but we're gonna do it in a kind of like a DFS to reach to the bottom of the tree, right? So remember, before we even handle any in-order traversal stuff, we need a base case, right, to break out of the function. So we're just gonna say if root is none, then we can return. Okay. So remember, we're gonna handle the left nodes first. So we're gonna say root.left, and we're gonna keep going into this function, going all the way to the left. Now at some point we're gonna hit that base case, right? At some point we're gonna hit this base case, and we're gonna exit, and we're gonna go to a given node. And that given node, right, could be the uh kth smallest element. Okay. Now, in terms of basically how do you know whether this is a third, second, fourth, or fifth smallest element? Is we're basically just going to add stuff to an array, and when the array length equals k, that's basically when we have the smallest kth smallest element, right? So we're just going to have a check to basically know when we can exit, so we don't have to actually add anything to the array, right? That's why we had an array called answer, and this is basically where the important stuff happens. We're going to say answer.append root.val. Okay. So, let me write a comment in case it is confusing what we're basically doing. So we're grabbing the kth smallest element. So for example, when we go all the way here, we're going to grab this 1 and we're going to put it into the array. The length of the array right now is just 1. Okay. Then we're going to go up. We're going to add the 2. Okay. Sorry, k is equal to 3, not 1. For example, 2 here. Okay. Is the length of the array equals to k? No. Now we add 3. So now the length of the array is equals to k, right? They're both this is of length 3, and k is equal to 3, right? So we don't add anything more to the array. And at the very end of this program, we're going to return the last element in this array, which should be our answer, because it would be our kth smallest element in the binary search tree, okay? So remember, we go left, then we go all the way left, and then we go back up. Well, when we hit like a null node, we go back up and we handle that node. But remember, we also have to go right. Right? Remember, we go all the way left, then we handle the root, and then we go to the right. Right? Boom, boom, boom. Right? It's better here, right? Then we go up, then we go right, then we go up, then we go right. Right? Because you're just grabbing the smallest element every single time, right, at a given point. So we grab the 1 first, then the 3, then the 5, then the 6. You can see kind of why this is so useful to solve this problem. So remember, we have to go right, so we're going to say in order. We're going to say root.right. Okay. And that should be it. Now let's call this function on the root, which is our input for this problem. Okay. And then remember, at the very end, we're just going to return the very last element in the array, and that should give us our answer. Yeah, this problem isn't too crazy. I just think this is actually one of the easier mediums, to be honest. Definitely some trickier ones out there, but I hope this helped. Don't overthink it, right? Problem isn't too hard. Just a basic in-order traversal problem, really. The only trick is you got to use this array here to kind of keep track of um what smallest element we're on. Are we on the third smallest element? Are we on the fourth? Right? And whenever that's equals to k, that's when you know you're done, basically. So, anyways, I hope this helped, and I'll see you in the next one. Peace out.